You're in a job shop, you want really fast turnaround, and you want to save money, you don't want to lose a lot of time. Like, you want to get through these jobs as fast as possible. Keep watching for some of my go-to tips. You work in a job shop or you do a lot of low volume, high mix manufacturing. You want to know if there's a better way than constantly tearing down all the tools and setting up more tools and seeming to always go back and reinvent the wheel. The answer is yes, there's a better way. One of the things that I talk a lot about with manufacturers is choosing a common set of tools for their machines. Now, and invariably, the next question out of their mouths is, what's the best blank? And so I'm going to share with you some of the tips that I use when I'm working with them so we can kind of get to the bottom of it. Today, I'm specifically going to be focusing on solid carbide end mills. As we're looking at solid carbide end mills, what's some of the main things? Well, I like to have a couple all-rounders in the machine. What do I mean by that? Well, if you have an idea of the smallest rads you typically see, let's say 1/8 inch is the smallest you see, or 1/4 inch. I mean, I've worked in a lot of shops where 1/4 inch is the smallest inside corner rad in a pocket that they would see. And so then you would want to have a 1/2 inch tool in there. You're going to want to go for medium length, not too long, not too short, kind of that Goldilocks porridge scenario. It's got to be just right. So something with 1/2 inch diameter, and then you're going to want to go for that 2.5 inch. Well, honestly, I really like the low length of cut necked down cutters. It's going to depend on the material and the type of reach you're doing. But I really do like the neck down cutters versus the solid long flute. It depends on your programming style, though. If you like to do a lot of trochoidal volume milling, any of that high efficiency stuff where you go down to and you get your big length and you go to town, which is a great strategy to have in that high mix, low volume scenario, then you're going to want something with about 4 times D worth of flute. Now, obviously, the rigidity, if I could talk, of the part as well as the rigidity of the tool are going to play into that, and the machine make and all of it. I usually stay 4 times D, 3 times it. Let's face it, if you're in a harder material and you've got to reduce your length of cut engagement, right? So you've got a high length of cut, you've got a lighter aerial, AEOD, radial engagement on the cut. I would usually drop the radial engagement to keep the length there, only for the even wear. When you've got a long flute end mill and you're just using the bottom corner, you're just prematurely getting rid of that end mill. So I'll go to the deepest cut that I possibly can. So having something 4 times deep seems to be that sweet spot. Now, as you feel it out, there's nothing saying you couldn't go to a longer one, but that's where I would go. And then invariably, it's like, okay, what brand, what series, how many flutes? And the answer is always, it depends. There's a big difference between setting up a grob or grobe, however you pronounce it, GROB. There we go. I'll spell it. I think I spelled it right. Or if you're on a Doosan or a Haas, right? There's a difference for how you're going to program your machines. Pro tip, actually, if you're having trouble with a certain machine make, chances are you just don't know how to program for that machine make. All machines that are currently popular out in the market all fill a niche, and I like to always say, a poor tradesman blames their tools. A skilled one finds a way. But I digress, getting off track. As you're looking for these 1/2 inch cutters, whatever, 1/2 inch, 1/4 inch, and then usually 3/4 or 5/8. And I would do that whether I was doing steel, Inconel, titanium, aluminum, and then what series would, well, that would just kind of vary depending on what material group you're on. I'm gonna switch and throw some video in the background. And the video in the background is the A3 series from GAR, which, funny enough, if you don't know, this series actually got started for those high mag spindles at really high RPMs. Like they're running at 15,000 right now. They're designed to run at 25,000 RPM. But then something special happened. They actually tried running it in low RPM machines, and the results were fantastic. It completely surprised them. Yeah, before I get mesmerized, I love watching it cut. Wow. So aluminum, right? Like the best thing in a job shop is if you have a niche of materials, or if you have machines kind of set up for different materials. It just, the goal is to reduce your setup time. Now, aluminum and steels, like the broad band, like say you're in a high mix shop, you're like, look, Arthur, I get a bunch of steel, I get aluminum, I get stainless, I get whatever, and it depends week to week, day to day. Then you're gonna want to go for a TICN coating. The titanium, I just remember titanium, to be completely frank with you. The TICN, anyway, I'll flash it up here on screen. So that coating, I remember when the first coating started getting popular because sales in cutting tools tanked. Like they dropped like way down. Because the tool life for the taps, Endmills, whatever you put that TICN on is just so much better in a job shop environment, that high mix. Now your material specific stuff, it doesn't really give them a run for their money, but it does an amazing job when you're working with mild steels and aluminums and stainless, and you're just constantly in that bend, 304, 316, back to 4140, then you're down to C12L14, and then you're down over to aluminum, and then you got all those different mixes coming through. You throw in a little bit of D2. Yeah, TICN is still good for D2. You've really got to modify your SFM for the D2 with TICN, but it still is a total tank, and it stands up really well, right? So that's the tips around that for selecting it. So size, look to see what your smallest rad is going to be. Like you can throw a quarter, then you can do down to an 1/8 inch rad for your end mill. Then you're going to want to have a 1/2 inch, 1/4 inch, and then either a 5/8 or a 3/4. You're going to want around that 4 times D length for the flute length. It's kind of that ideal, or a neck down cutter just so you can get that reach. Like a 3 times D with a neck down. It's beautiful. And then coating wise, if you are blessed enough to have your machines or your niche in your shop to certain materials for certain machines, then you can totally go material specific with your coatings. Otherwise, you're going to want to look for TICN coated because it's just a brute. You'll still get a great tool life out of it. You'll still get good production out of it. And having a tool in your machine that's just ready to go, that's what's going to save you so much money. Because if that spindle's not turning, then you're not earning. Thank you for watching today's video. I really do appreciate you taking time to watch these, to see what's there for you. And it would be awesome if you could support me in my journey to reach 100,000 machine shops, manufacturing plants. I mean, machine shops, that's who I work with. Because I want to really transform manufacturing, and it's like not some weird out there kind of idea, but I want to help manufacturers save money, make their jobs easier, and make everyone's time at work a better place. And I'm coming at it from the side of partnership and tooling and really getting that cohesive unit working together. Because when there's less BS, everybody wins. Thanks. Don't forget to hit subscribe, hit like, turn on that little bell. All of those things help more people in the world see these videos. And if you're here watching this, taking value from it, why wouldn't you want all of them to be able to benefit as well?